Good morning, everybody. Today we're going to look at how we use graphs in science and what types of graphs that we can use. Now, in science, we use graphs as a way of displaying information or data in a visual form. This will make it easier to detect patterns within the data. Data is simply information that is gathered during an investigation or observation. That information can be numerical or it can be in words, as you'll see in a moment. The three types of graphs that we have are the line graph. Let's talk about the line graph for a moment. A line graph is used when you want to show how a dependent variable that's plotted on the y-axis of a graph changes, I left out a parenthesis, changes because of a change in the independent variable. Now, remember, the independent variable is the one that you choose certain values for. You decide, I want the independent variable to have values of 5, 10, 15, 20, 25, and we'll see how that affects the dependent variable. So the independent variable you choose values for, and then you measure how the dependent variable is affected by that. The independent variable goes on the x-axis. The dependent variable goes on the y-axis. Okay? Now, the line graph over here to the side shows the average monthly rainfall that varies through the year between two different cities. Now, notice, line graphs show how relationship changes over a period of time, in this case, a full year by months. January, February, all the way to November and December. And because you're comparing two different cities, you have more than one data line plotted, and we use different colors to distinguish one set of data from the other. Okay? Another type of graph commonly used in science is the bar graph. Now, a bar graph is usually used when you want to compare information that is collected by counting. For example, the amount of different types of school supplies used by students. There are categories that are compared, and then the counts of those supplies are on the y-axis. So the type of supply is the independent variable, and the number of each type of supply is the dependent variable. Again, it's still independent on the x-axis, dependent on the y-axis. It's just that here, the independent variable are categories, not necessarily numerical information, just categories. Bar graphs can be used to compare products, finances, all sorts of things. Now, at this point, you're going to want to pause this video and you're going to maximize your digital copy of the document. Then click on the link within the document, this link right here. Watch the video on bar and line graphs. When you are done with that video, come back to this video to continue the notes. Now that you've seen the information about line and bar graphs, we're going to look at one more type of graph. Even though this particular type of graph is very seldom used in science, it is still important to understand what it looks like and how it's used. And this is called the circle graph. Sometimes you'll see the circle graph called a pie chart. And that's because the pie chart is broken up into slices like a pie. A circle graph is used to show how a fixed quantity can be broken up into parts. The entire or whole circle represents 100% of the fixed quantity. The slices show you how much of the fixed quantity is devoted to a particular item or category. For example, in this case, you have the order of vegetables that a restaurant uses. And the order is based on the whole order is based on the percentages of the various types of vegetables they use the most. Obviously, this bigger pie slice, which is 30%, is used the most, and those are the potatoes. So they use more potatoes than they do any of the other vegetables. Now, at this point, please pause this video for the notes. Maximize your digital copy of the document again and click on this link and watch a short video about pie charts. Then come back to this video. Now that you've watched the little video on pie charts, let's go back and look at line graphs. These are actually the most common graphs used in science. So, suppose in an experiment you check the air temperature at certain hours of the day and you recorded the information in the table shown below. We're going to graph this information and see what kind of patterns we can detect. Please remember, the independent variable is the one that you choose certain values for. The dependent variable is affected by those chosen values of the independent variable. So let's look at our two. Remember, we checked the air temperature at certain hours of the day. So in this case, we chose the hour of the day at which to measure the temperature. So the time we chose, that would make it the independent variable. The resulting temperature measured depends on the time of day chosen. So that's the dependent. It will go on the y-axis. Independent on the x, dependent on the y. So let's start. Okay? First, let's title our graph. Since we're talking about the temperature at different times of the day, let's just title it Temperature During the Day. That's pretty good. Okay, let's look at the independent variable, the time. That's going to go on the x-axis. So the first thing I'm going to do is get a straight edge, and you want to do this one too. Just get yourself a straight edge. It doesn't actually have to be a ruler, just something with a straight edge. Now remember, the horizontal axis is the x-axis, and that's the one we're going to put the independent variable on. So this is the time. Okay? Now, look at the range of our data. Our data goes from 8 a.m. until 4 p.m. So I would suggest we do this. We start right here at 8 a.m. And then we go to 10, 12, 2, 4, 6 a.m. Or actually, that would be p.m. then, wouldn't it? Okay. So, right here would be p.m., noon. This is a.m., and this is p.m., and this is p.m. Okay. There we go. We went by 2-hour time intervals. 8, 10, 12, 2, 4, 6. Okay, now let's look at the other data. We're going to do the temperature. That's the dependent variable. It goes on the y-axis. So I'm going to use a straight edge, draw the y-axis. Now we're going to label it for temperature. Okay? Now, how are we going to do this? Our range is from 27 to 30. So maybe we want to go from, say, 25 up. How are we going to do that? Are we going to go by ones or twos? Well, 27 to 32, our range is 27 to 32. Yeah, 27 is the smallest, 32 is the biggest. That's a range of, let's see, 5 degrees, I believe. So we want to spread it out. The more we spread it out, the easier it is to see the patterns. If you squish it all down here, you're not going to really see much of a pattern. So always spread it out along your axis. Now, since we have a total of spread of 5 degrees, I would suggest we do it this way. Here's 27, 28, 29, 30, 31, 32. And this is going to be degrees Celsius. Okay, now to plot. Just start on the left to go over and then go up to the temperature. So over, then up. So here I go. 8 a.m. up to 27. Make a point. All right? Don't make it too big. The points are not blobs. Now we're going to go to 12 p.m., over to 12, up to 32. So we go over to 12, all the way up to 32. All right? Then over to 4, up to 30. Over to 4 p.m., up to only 30. Right there. Now that we have our 3 points plotted, we can connect them with straight lines. There we go. And yeah, I got a little bit overly excited on that one apparently. There we go. That gets that out of the way. All right. So here's our graph of the temperatures during these time periods. Now, let's analyze this graph just a moment. I have some questions here we're going to answer by looking at our graph to see what patterns we can see. The first question is, based on this graph, what was the temperature at 10 a.m.? Well, how are we going to know that? That's not in the data. Oh, but it is on the graph. If we go over to 10 a.m., we simply follow that up to the graph line and see what temperature we had at that point on the graph line. Well, it would be 29.5 degrees Celsius. So the temperature at 10 a.m. was 29.5. See? That's pretty easy. Okay, look at the next question. What was the temperature at 2 p.m.? Again, there's no data for 2 p.m., but if we go to the graph, we can follow from 2 p.m. up to the graph line, and we can see what the temperature at that point would be, 31 degrees Celsius. Okay? And finally, what is the relationship between the time and the temperature? Well, what do you notice as the day goes on? The temperature rises until about midday, and then it decreases. So, would that happen every day, do you think? We live here in Florida. We know it gets really hot midday, and then it cools off in the evening. Starts out cooler in the morning, gets really hot during the day, and then cools off by the evening. So, what can we say about the relationship between time and temperature? We can say the temperature increases from morning to midday and then decreases. Pretty cool. Okay, at this point, there's one more interesting little video I want you to watch about interpreting and drawing line graphs. Because again, line graphs are the most important types of graph in science, and we'll be doing lots of line graphs. So pull back up your digital document that you minimized, pull it back up, and click on this very last link. Watch the video, and then that's all there is today. Thank you. Bye-bye.